video, let us see what is stationary point and critical point of a function and the difference between these 2 points, stationary point and critical point. Y is a function of x. x0 comma f of x0 is said to be a stationary point if first derivative is 0 at that point. F dash x0 is 0. Then let us see what is a critical point. Critical point is a point where first derivative is 0. x0 comma f of x0 is said to be a critical point if first derivative at that point is 0 or does not exist. All the stationary points will be critical points because here you can see f dash x0 is 0, f dash x0 is 0. But all the critical points need not be stationary points. All the stationary points will be critical point, but all the critical points need not be stationary point because here does not exist. Critical point is a point where first derivative does not exist. Now let us see an example. Y minus 2 is equal to x minus 3 all square. So this is a parabola. You know the standard equation of a parabola whose vertex is at hk. Y minus k is equal to 4ax minus h all square. Now this is a parabola whose vertex is at 3 comma 2 where x is 3 and y 3 comma 2. Now this can be written y minus 2 is equal to a minus b all square, so a square minus 2ab, that is 6x plus 9. Rearrange this, minus 2 you take to the other side, so you will get y is a function of x. Y is equal to x square minus 6x plus 11. So y is a function of x. Now let us get the first derivative f dash x. So derivative of x square is 2x minus 6, derivative of x is 1. Now for getting the stationary points, equate it to 0, first derivative. When you equate first derivative to 0, 2x minus 6 is 0. So you can take a 2 outside. Now x minus 3 is equal to 0. That means x is equal to 3. When x is equal to 3, first derivative is 0. Now you put for this x 3, so 3 minus 3 is 0. So y minus 2 is 0. That means y is 2. So 3 comma 2 is a stationary point. Here first derivative is becoming 0. Now before this 3, you put 2 here. So 2 into 2, 4. 4 minus 6 minus 2 is negative. So before this first derivative is negative. Then you take a value after 3, that is 4. 2 into 4, 8. 8 minus 6 is 2. So it's a positive value. So here first derivative is positive. So here sign is changing. So this is a minimum point. It's a lowest point on the graph. So here first derivative is 0. So it's a stationary point. To find the maxima and minima, this idea will be useful. Here first derivative is changing from negative to positive. Y is equal to modulus of x minus 3. So modulus function. Now this is the graph. So when x is 1, 1 minus 3, minus 2. So modulus of minus 2 is 2. So when x is 1, y is 2. So you can see it's going on decreasing and then increasing. Then, but here first derivative does not exist here. So when x is equal to 3, y is equal to 0. So 3 comma 0 is a critical point because their first derivative does not exist. So this is not a stationary point, it's a critical point. First derivative does not exist. So stationary point is a point where first derivative is 0. So this is a critical point but not a stationary point.